find it now. There we go. Right. Good filters are essential in modern day radio environments. Now, the difference between us and the rest of the world is that we build our own kit and nobody else tends to these days. And for the rest of the world, Yaesu and ICOM in theory fit them for them. So if you buy a modern rig and take it to pieces, which guess what, we all do, don't we? Well, I do. You will find there is quite a lot of filtering on board at a lot of levels, at drivers, at the PA stages. And the problem is that we're a bit unique because we build stuff, and that's really why we all love this hobby. But it does mean that we have to take some precautions to make sure that we're doing things correctly, and that's on both transmit and receive. And what we discovered a couple of years ago when we started the RBTV stuff, that we had to dust off the textbooks and discover how to build filters again. So all I want to try and get over today is, what does it say, resume slideshow? So I click that. All I want to do is get over that, you do need them. A lot of people watching this may well say, well, why? I know it works without them. Well, I'm speaking from experience here. I'm not going to tell you what that picture is about now. I'll tell you at the end, okay? But it's GKQ and GTZ out portable. But the message is, on receive particularly, there's a lot of loud signals out there. If you just look on an analyzer, if you look on your SDR, particularly around band 2, 144-800 is another favourite place, digital TV signals. And one of the problems we have today is that a lot of these signals are now digital. You've got DAB at 200 megs, you've got all the TV is digital, and it just raises the noise floor and you cannot hear it. The other problem that we've got is a self-induced problem, is that we use satellite tuners, and they are inherently wideband. So although we're tuning them to 437 or we're tuning them to 146.5, they're actually 10, 15, 20, 30 megs wide, because that's what they were designed for. And so they were also designed to look at the sky, if you think about it. A satellite tuner into an LNB looking at the sky. And so there were no big signals other than the signal that's on the actual satellite you're looking at. There's no real band 2 signals. There's no digital TV transmitters up there. They are meant and designed for a specific purpose where it's a relatively clean environment, whereas we're trying to use them in a pretty hostile environment. And so it's essential to use bandpass and notch filters on receive. I still haven't convinced you? Do I really, really need to? Well, Brian and I got given a couple of certificates earlier on, and that was for a contact we did from the Isle of Wight. And actually, that's Brian's signal there. He was up, we think he was up in Shropshire. We can't remember exactly where he was, but we were on the Isle of Wight. That's his signal there. Oh my goodness, where's his signal on that one? And the difference there is, that was using an SPF without a bandpass filter, a tight bandpass filter, same receive system with a bandpass filter. How many more times do I have to say it? On receive, the problem is you don't know that you need a filter. You only know that you're not receiving the other signal. So, that's an SPF, one of the SPF DDK preamps. You've got to use filters. And they need to be bandpass. The reason they need to be bandpass is because they need to filter both high and low of the wanted signal. So you just need to take the bandpass that you want to hear. You need to be able to protect against mixing products which can come in. There was a discussion on the UK Microwave Group forum about a month ago about the new SG transverters on 1.3 on 23 SEMs, and people have had problems with those because there's been mixers from the 1.9 gig mobile phones, and there was a product, and I can't remember what it was, but a product ended up back in 23 SEMs unless you had bandpass filtering on the front end. And you need them to be as tight or as narrow as possible. Maybe include a notch for band 2 or the TV transmitters, or even 144/800. The packet can be very loud on some of these portable sites, and so there's a couple of designs around for a notch, a single notch, which is just a notch on 144/800. So a couple of precautions is, of course, the problem when you start playing around with preamps and filters is you generally power your preamp up the coax, and most filters are generally short circuit. You can imagine what happens. And if you're going to start to put your filter in front of your preamp, you need to make sure, as well as having a high Q, good rejection, it also has a minimum insertion loss. So here's another debate to have. Do you put it before or after the preamp? Well, never mind that. This line is always true. Always put your preamp at masthead. Now, I know Rob doesn't. He thinks it's easier because when you're out portable, putting preamps at masthead just creates more problem. But just think that at 70 centimetres, 20 metres of RG213, which is not an exceptional run for a home station, that's 3 dB. So the guy at the other end can increase his power from 50 watts to 100 watts, and you just throw that away by running your RG213 with the preamp in the shack. So wherever is practical, always put your preamp at the masthead. So that does involve powering up the coax, probably. Modern devices have a noise figure of less than 1 dB and can handle large signals, but the general wisdom is that for terrestrial links, your noise floor, the noise level of just general terrestrial noise, is around about 2 dB. So you can afford to put the filter in front of the preamp. And I've certainly learnt the hard way on 70 SEMs particularly to put an interdigital filter in front of the low noise preamp and then put it at masthead. On 146 you have a good alternative. You can use a preamp with, sorry, not just 146, but the other alternative is to use a high tuned preamp with a very good input. Dave, I know, uses the 3SK88, that original design with the slab, which was produced in the 1980s.
From Radio and Electronics World.
Yeah. Or on 2 meters, Ian White has, GM3 SEK, has done an excellent preamp, the DG8 preamp for 144 to 146. And that's what I run on 146 now. And that has got filtering in the front end. And if you want to read about the theory behind all of this, have a look at Ian's paper on the DG8 preamp on his website. If you just Google GM3 SEK and then DG8 preamp, there's a whole paper describing all of this and giving you the ins and outs of what you shouldn't be doing.
Could I just say, no, RF Design do an excellent 70 SEMs filter preamp.
And RF Designs do an excellent, absolutely excellent.
Got them next door if anybody's interested looking, and it's 2-stage filtered amp.
There we go. So Jean-Pierre produced this a long time ago. Using mini tuning, he proved exactly this point. So what you'll see is the top picture. You've got an RF level of 36 dB with an MER and a nice constellation of 18 dB. All of these pictures have got an RF level or a received signal level of 36 dB, but the MER gets worse. And that's because you can't rely on the S meter to tell you what's going on. These effects are caused by interference, caused by and poor noise floor. The fact is that we have to protect ourselves against the noise in the environment. So what do we do in practice? Well, interdigital, and they're not called digital because they're digital. I presume they're called digital because they're digits. Lots of designs around. That's just one. I mean, I have got some in the car. Loads of designs around. They're mechanical devices. So anybody with a drill and a soldering iron can make an interdigital filter. They can be made from PCB or W1GHZ. His name has cropped up quite a few times this time round. Has got designs for comb line filters using Altoids tins, but he also does some better designs using slab metal in Hammond boxes. Some excellent filters, and you get that sort of shape. That's the DG8 design by Ian White, and this is designed as a contest preamp. But look, he's got filtering on the front end before the front end device. He knows that to put proper filtering there is a good compromise to getting a high performance preamp. But more filtering after as well. That's a picture of it over there. Right, CAT17 DATV, Sean, JVPG, reproduced, I think it was a Ragcom or a RSGB handbook, VHF, UHF handbook. And David, where's David? You're there. DYH built one and brought it along today, or yesterday, and we had a look at it. And that's what it looks like. That's 50 meg span, so it's about 5 megs wide. But what that will protect David against is the pages on 139 and the PMR and the nasty stuff up at 160. Very simple design, easy to make, but in front of his 146 meg preamp, he will probably be able to hear stuff that he couldn't hear if he didn't have it in there, particularly if he goes up to Clea or somewhere like that. Can we pass it around? Yeah. Can they touch the magic red wire?
Touch the magic wire.
So there's a bit of debate in that on the forum about the coupling capacitor between the two stages, this capacitor here, and you'll see from there that it's purely a loop of wire into the second chamber because it needs to be very low. Now, actually, I did have a picture, but we had another one here which had got a higher value capacitor there, and it was flat because it was overcoupled. It had lost the Q, and it just rolled off, probably 50, 60 megs wide. Yeah. So the message really is on receive, you will pay the price if you don't put preamps, if you don't use filters in front of your preamps. On transmit, one of the things we have to remember is these are wideband devices. The Portsdown is a wideband device. DATV is a wideband device. Pluto is a wideband device. So if there's any harmonics generated in there at all, they'll just come straight out of the socket, the aerial socket. So it's up to you to be responsible and filter it. I mean, just try tuning to 439.5 when you're transmitting on 146.5. Works a treat. You can, yeah. So all you need on transmit though is you need to remove those harmonics generally, and that is a low pass filter above the frequency you're using. Not just a low pass filter, but something that rolls off. If you're on 70 centimeters, it probably rolls off at 500 megs to make sure you remove that third harmonic. And the other thing about transmit filters, of course, they need to be after the power amplifier, and so they generally need to be able to handle watts So therefore they tend to use AVC or specialist capacitors, so it's probably better to buy rather than build. We did have a picture of this mini circuits and I forgot to put it in.
There's a real one in your box there.
Yeah, but that's this one. Little mini circuits. How much are they? How much were they?
Is it 20 Aussie dollars? I'm not sure.
Sorry?
But it's in the amplifier, it came to about 70 quid.
Yeah, I mean, they're not expensive. So you're probably better off buying something to go in the transmit output. And we can pass that one around and get that one damaged as well.
More robust.
So, don't learn the hard way like I did. No receive filters can be a showstopper. You know, your tuner will crunch and you won't know it. And that's what this picture's about. So Dave and I went up to Portsdown Hill to receive Charles, who we heard just before lunch, who lives along the coast at Worthing. And we were doing some DVB-S2 experiments, some of the first time DVB-S2 had ever been transmitted. And we were parked up and Dave was here and I was here. I couldn't receive anything.
Pictures are fine. No problem, Noel. Good pictures.
Strange this. Can't see anything. I had a preamp up at Masthead even. And I think Dave had the cheek to put his preamp on the grass and mine was at Masthead and I still couldn't see anything. Guess what? I mean, what we learnt later was that Portsdown Hill is a filthy RF environment. It is horrible. Because those of you who know Portsdown Hill, it's right above Portsmouth. It's where all of the naval research and radar stations are. We were up the far end. You look at it on an analyzer, it's like that. But I learnt the hard way. You know, RF filters, you don't know that you need them. Sorry, receive filters. You don't know you don't need them until you don't receive anything. And transmit filters are just good practice, really. You do need to put them in there. And that's a bit like just not overdriving your power amplifier, which brings us on to the second one. A couple of slides and then Dave's going to give you a demonstration of what happens when you do what you shouldn't do. And John Regnall, G4SWX, who's the VHF manager, is very, very keen to stress that it's not just the DATV boys who need to watch this. That any digital modes are particularly hard on power amplifiers. Now, spectral regrowth, which is this business that we call the shoulders, is hard to achieve. And professional satellite uplinks, the ITU spec is for only, I think it's minus 28 dB shoulders. So that's a fairly typical professional satellite uplink. But there again, they don't have to worry about it because it's only the satellite. On 146, because we are in that half meg we've been given and there's lots of other stuff going on outside, we were given the target to get for 60 dB down, and that's tough. And so what we have to do, not just on 146, but generally, is back off the PA, particularly if it's an older type technology PA. You need to back it off by anything up to 10 dB. So that means if you've got a 10 watt amplifier, you can only run 1 watt clean digital out of it. And these are some pictures we've published in CQTV Times. Top one is Rob. That was an RD70 device, which is a 70 watt device, and that's running 5 watts. A few of us, including myself, run the Mitsubishi 60 watt module, and I can get about 7 watts out of that. Takes 5 amps at 12 volts. That's 60 watts in, and we're getting 7 or 8 watts out. So you need good heat sinks, you need big fans and big batteries, but you can do it, and it's essential that you do it. And I think we're now going to show you why it's essential that we do it.
Okay, this is that module that Noel talked about. I'm driving it from a Portsdown, which isn't perfect anyway,
Can we zoom in on the scope screen? Just look at what's showing. Move that over. Okay, so that is, in fact, it happens to be 2 mega symbols because that's easiest to show. The shoulders that the ports down lets out are down about there. So, what's that? Minus 45-ish. Which is this isn't a mode we'd normally run on 2, it's just easier to show it. But as I wind up the power, hopefully you can see the power at the top's going up, but the shoulders go up disproportionately. We're now at minus 30 on the shoulders. That's a 70 watt brick, and that's about 15 watts output. So you really do need to wind them down.
Yeah, and as the slide says up there, if you're running 5 watts and you manage to screw another 1 watt out, it won't make bugger all difference on your receive signal at the other end, but it may increase your shoulders by up to 5 dB.
And I think we need to be realistic about this. At 146, it's important because we've got stuff either side. In 10 gigs, if we're in a bit of 10 gigs...
Does Dave need a microphone?
Sorry. If we're in a bit of 10 gigs that nobody else is using, it doesn't actually matter if those shoulders are a bit bigger because you're not interfering with anybody. But what we've found is as you raise the power, you start going into limiting and the MER goes down. So you're actually being counterproductive. Your power needle is going up, but there is this sweet spot where you get the maximum signal to noise at the far end. So be realistic about it. Think about what you might be interfering with, what our legal requirements are, and what you need to achieve.
Yeah, I think the message there is try and get we know not everybody's got an analyzer, but do try and get your gear on an analyzer. Note down the numbers and then don't touch it. Don't be tempted to go for that extra little bit because it won't do you any good, and all you'll do is just pollute the environment. So it is 5 watts plus a watt is less than 1 dB, but could make things a lot worse.
So do you underdrive or low drive you talked about that Mitsubishi module, for example. Do you achieve that by attenuating the input somewhat, or do you achieve that by setting the bias lower?
The input.
Right.
So
you
your
bias it
will...
as normal.
Yeah.
In fact, you set the input. You set the input low. The way I would do it is you set the input low and then adjust the bias for look. If you've got an analyzer, looking on the analyzer for the cleanest signal, then tweak the input a bit more, and you get this compromise where the sweet spot again on the bias, the input level, and just shoulders.
Yeah. Any other questions?
Just to say,
Yeah, take the question.
I'll take Paul and then come across to you, Jeff.
There are some very linear amplifiers around. I saw one in the other building, a stealth microwave one. Some of these have very complex amplifiers, but presumably you can run those at much nearer to their declared power.
Nearer, but not...
That's the feed-forward correction. It uses 2-stage feed-forward in a stealth microwave.
Or dirty amplifiers.
And you can run those, I reckon, about 75%. Yeah.
Thank you.
Can you pass the mic to Jeff, please?
Jeff, G4HIZ. All I was going to say was this business of the reducing MER when you get up there is more likely down to phase distortion. You get AM to PM effects, and basically if you look at a constellation, it gets bad.
Yeah.
I've actually found this with the two-tune receiver. If I'm doing a test too close, I can overdrive the input, and it does the same trick. So there we are. Plenty of headroom needed in your amp, basically.
Something you pointed out earlier about filtering the output of things like Portstown and DATV Express. Something that occurred about 30 years ago actually was to do with an ordinary analogue repeater. We kept blowing the driver in the PA stage of the repeater, and we couldn't work out what it was. And it actually turned out it was the third harmonic of the transmitter coming out in the 23 SEMS band was causing a mismatch between the first and second stage of the PA and actually blowing up the driver.
Yeah.
And it was when we put a filter in between the actual output of the transmitter and the PA that we stopped blowing the driver.
Yeah.
So it's just a technical point as well.
Yeah. It's the black art.
And spectrum analysis is getting a lot easier these days. You remember an RTL SDR, for example. You can, if you're running 333 kilosymbols, you can use an RTL SDR, which are 10 quid on eBay, and a PC, and you can look at your spectrum. So you don't need all this kit that's taken me 30 years to build. You can just... Sorry? Or a Pluto. Yeah, Pluto will give you a lot more bandwidth, but you can do it really cheap. So do look.